Hello learners, welcome to this session on the basics of an 8-bit microcontroller called 8051. The objectives of this session are to have an overview of the components of microcontrollers, then to explore the typical components and their functionalities inside the 8-bit microcontroller. Let us see the major components and their roles in an 8-bit microcontroller. If you look at the major components are the very first component called the microprocessor, a major component for computing, controlling and triggering every operation in microcontrollers. This has a channel as bus, which is nothing but parallel electric wires through which the microprocessor will get connected to all other parts. For quick storage, come access of any instruction as well as data, we have a memory block connected with the microprocessor. The next block, if you look at, any input or output connections are made possible through a general I/O ports which are connected through the bus with our microprocessor. Next, there are timer blocks that are used as counters and timers to track either the internal or the external tasks or events. The microprocessor is also connected with the various interrupts which are actually reacts to events. The key inference in all the above subcomponents are they are all built as one single integrated chip. We know that the microprocessor is the heart of the microcontroller. It is responsible for the arithmetic logical operations, storage control, input-output control, speed matching between different devices, interrupt attention and stack memory related operations. It does all the operations with the help of the buses. Any sensing, sequencing, computing, recording, alerting and actuating functionality depends on the capacity of the microprocessor inside our microcontroller. Now let us see our key functional block of the microcontroller. Next one, which is called the memory. We can visualize the memory of microcontrollers in different categories. First category, on-chip memory or otherwise called internal memory. And second category called external memory. Many microcontroller series have versions of microcontrollers like ROM-less versions, meaning there is no read-only memory. Second type, EPROM versions. They have EPROM inside. EEPROM versions. They have EEPROM on the chip itself. Like this, we have different versions. Thus, we have choices of 8051 memory configuration as with on-chip RAM alone. Second type, with RAM and EPROM. Third type, with RAM and EEPROM and external memory support. Now let us have some insight on the memory device choices for the microcontrollers. The choices are, the memory IC may be volatile, under which we have static RAM, denoted normally as SRAM, and dynamic RAM, called DRAM. It may also be non-volatile, under which we have ROM, that is read-only memory, then PROM, that is programmable read-only memory, then EPROM, that is erasable programmable read-only memory, or EEPROM, that is electronically erasable programmable read-only memory. Talking about the model of memory, 8051 has Harvard architecture, which means the program and data memory are available separately. On-chip memory is available to hold the program and data and is helpful for the quick execution. Based on the need, we can connect external memory also. Now, in specific in 8051, when we look at, there's 128 bytes of on-chip RAM, which is used as a data memory. There's another 128 bytes of special function registers. Then 4 kilobytes of on-chip ROM, which is helpful for the program storage or otherwise called program memory. Now our next focus is on to I/O ports. I/O ports are required for the purpose of interacting with external devices or machines or peripherals in any real-time applications. Using I/O ports, we can control and monitor the hardware. In general, the I/O pins are 8-pin ports. This will give us a comfort to access 1 byte of data, which is of 8-bit length in the 8-bit microcontroller. So in 8051, we have 4 I/O ports, which are called as port 0, port 1, port 2 and port 3. All of them may be configured for both input and output operations. Thus, 32 pins are available for the peripheral interface facility. Port 0 supports for the external memory interface too. Next, let us learn about the bus control. What is a bus? It is used as a communication medium. 8 or 16 or more wires combine this bus structure. 8051 has 16-bit as address bus and 8-bit as data bus. The next block of discussion is on timers. For providing a delay in the task, for time stamping, to trigger interrupts on time, for providing waveforms, to have a motor control operations, we need timers or counters. We have 2 such timers in 8051, each of 16-bit length. They are called as timer 0 and timer 1. They are normally configured and controlled through a control register called TCON. We have 4 different modes of timer operations. The final and important block of interest is interrupts. Microcontrollers need to react to the events. Events in our example, what we have seen are the low level of the indicator of the water level and the high level indication of the water level. This may use polling process or interrupts. Polling has a drawback of processor time being wasted. For this purpose, normally polling is avoided and interrupts are used. By sensing the request as an interrupt, the microcontroller switches its control from the main program to the interrupt service routine called ISR. 8051 has 5 such vectored interrupts. 3 of them are internal and 2 of them are external interrupts. There are interrupt enabled and interrupt priority registers which are used for configuring these interrupts as shown in the figure. As per the principle of interrupts, the occurrence of interrupts drives the processor control to switch over to the interrupt service routines. To summarize, we discuss the internal structure overview of 8051 microcontrollers. We had brief learning on the key blocks like memory, I/O ports, bus control, timers and interrupts. Detailed study on the above blocks and their configuration will be discussed in the subsequent sessions. With this introduction on 8051, let us continue with the pin diagram and functional diagram in the later sessions. Thank you, learners.